Today we're going to start having a look at motion. We're going to have a look at velocity, distance, speed, time graphs, and probably some acceleration. So let's go and have a look at what we're going to be doing. Here I've got a aluminium track, and on this I've got a little cart. This is actually a smart cart, and it will transmit to the computer the relevant details about its distance, its speed, its acceleration. So we can work out velocity, acceleration or distance on this. It's also got a little visual thing on it at the moment, so I can measure the acceleration and you can see what it's doing. So it's set at the moment to acceleration, but I can change that to velocity and other things. So what we're going to do is we're going to take this, we're going to push this down the track, and it's going to collide at the bottom and it's going to return. So this is our basic experiment we're going to try first off. Now, to do this experiment, then I've got set up a recorder for the position, the velocity and the acceleration. I've just had a practice to see whether it worked or not, so it did. So let's set this recording and let's see what we're going to do as we push this. So I'll just give this a little push, and we can see it move down the track and come back. Let's do this again, but this time watch the screen. I wanted the other one on. And it's returning back where it came from. Let's have a look and see what we've got with this. So if I go back and look at the screen, then looking at the position, first of all we gave it a push, and you can see this is not exactly a straight line. It is in fact slowing down very, very slightly as it moves along. When it gets to the bumper at the other end, it returns and comes back in the opposite direction, and it collides with the other end. I held it, didn't move, and then I gave it another push, this time much gentler, so you can see it slowed down more and more and more, and coming back it slowed down, and I stopped it before it got to the end of the track. Looking at what's happening at the same time, let's look at the velocity. It's not moving. We had an enormous increase in velocity, very sudden, and then this is slowing down. The velocity is gradually decreasing, then it hits the bumpers at this point. It suddenly goes from going one way to going in the other way, and it continues to slow down until it hits the bumpers at the other end. I repeated the experiment. If we look at the acceleration, there is a sudden bip in acceleration, and then the acceleration stops, then it collides at the other end. There's a sudden change in acceleration going the opposite direction, and no more until it collides. So let's just do this once more. Now we know what we're looking for. So what we're going to do is I'm going to set up this track again to go. So we've got the track ready, the experiment is recording, and I'm just going to push this down the track. and this time I didn't give it enough push, so it got to this end and stopped. Not moving. A little acceleration. We can see the velocity then decreasing virtually to 0. Let's give it a harder push. That was too hard, I just pushed it back to get to the other end. So let's try giving it a harder push. So I'll set this to record, and you can watch the cart this time, and I'll give it a push. We can see we've got a velocity here, and what we can actually do is we can actually measure the steepness this to give us our velocity. I don't need to bother because I've actually taken the velocity graph as well, and we can work out what the velocity is here in meters per second. And I can look at my acceleration. The vector display on it, I can set this to run for velocity, and if I look at my velocity here is going up to about 0.8. So on my vector display I'm going to set this so it can go up to 0.1, but we're going to set it up to 2 meters per second. So that should give us some inkling what's going on. So let's look at this experiment again. I'm going to run it again, but this time watch the cart, and you'll see on the cart arrows. You see the red arrow and the green arrow. Let's try it faster. And too fast for that. And it came off. What I'm trying to show though is here our velocity. I managed to sort of double the velocity. It went from about 0.7, probably about 7.5, and here we got it up to nearly about 1.4, near enough. And you can see my acceleration. Right, let's do a new experiment. So I'm going to do File, New Experiment. I'll discard that data, I don't need it. And let's see what we're going to do. We're going to look at a very simple one. I'm going to record here the measurement. Let's record just the position, and I'm going to record that against time, and I'll do the same on the graph. So same experiment, but I'm going to try and do it a couple of times to see what happens. So let's try first of all looking at this. Here's the cart coming along. And returning. So what we can see here is this sort of classic sort of shape. We're stationary, we're moving away at a constant, really, yeah, more or less a constant velocity. It is slowing down very slightly, and we can see that by looking at the data that it wasn't moving, and then it is moving, and we've got here position moving away. I'm lucky that I did actually record the velocity, and you can see the velocity here is about 6.7, 6.7, then 6.6, then 6.5, then 6.4, 6.3. It is slowing down, and we could compensate with that by adjusting the track if we want to, but I can only adjust it in one direction. We could look at the position here. You can also look at the velocity graph, and you can see how the velocity is in fact coming down. But I want to do this experiment again, but this time I'm going to push it much slower, and I'll set the multiple recording on so that we can see what's going on. So let's push the cart again. And you can see here we're going very much slower. Graph. It's travelled the same distance, but if we look at the velocity graph here, we can see that the first one had a higher velocity than the second one. And if we repeat this experiment a third time, and that'll fool everything by having a quick push. Let's make it go faster. Just about what it can survive for full speed, that. And we can see that we've got our three velocities. We've got our slow, our medium, and our fast, and we can record those. And each one of those we can see it is in fact slowing down. The velocity is not constant. The distance, however, it travels, we've got the same sort of distance. I upset this one by moving it back to start with, but if I measure that distance from there to there, it is the same height. Position wasn't a good one to move there. And then I can also measure the acceleration spikes, and we can see that we've got a small acceleration, a larger acceleration, and a larger acceleration. So we've got here our equations for constant speed. Constant speed is distance over time. Now I'm going to do another experiment using the same sort of thing, but this time I'm going to use a different way of doing it. And if I can get you on the camera for a minute. Now, what I'm going to do with this one is I've got a different sensor set up. I've got a different sensor down here which we're going to have a quick look at, and I'm just going to zoom in on it. This is an ultrasonic sensor, and this ultrasonic sensor sends out a beam of ultrasound, and that is going to hit me, blocking it. And what I'm going to do is I'm going to walk down with this ultrasound sensor watching me, and then turn around and come back. So let's see how to do this. So the first thing I need to do is set it up, and I'm going to do that by having a new experiment, file, new experiment, discard the other information, I don't need it, and I'm just going to set my hardware up, and I'm going to add a new piece of hardware. So I'm going to switch on this ultrasound sensor, and I can detect it. And it says it's got a motion sensor on it. So let's have a look at recording here on the motion sensor, the position, and I'm going to just do the time, and we'll see if we can do the same thing on this one. So I'm now ready to start, and let's just put the camera on me. So what I'm going to do is I'm going to stand in front of this sensor. You can't really see anything when I do this anyway, so it's not going to make much difference. I'm going to stand in front of the sensor, and what we're going to do is we're going to start the system, and all I'm going to do is I'm going to walk towards the camera, I'm going to stop, turn round and walk back again. I'm going to be basically my own little smart cart. So let's start the computer, and it's starting to record, and I'm going to move at a constant speed here. Let's turn round, and I'm going to move back towards the sensor. And if you can stop it for me, we'll see what we've got. Then looking at the other system, I don't particularly make a good smart cart here, but let's see what we can see here. I'm not moving. Alright, I wiggled a little bit. And then I started moving away from the object until I got to the camera. At the camera I stayed still. Then unfortunately I turned round, and I'm not basically nice shape according to the system anyway. What it was looking for would be something nice like a cylinder, but unfortunately I'm wider than I am front to back. So we get here some sort of wiggle, and then I start to move back towards the sensor, ending up where I started. And something went wrong there, I don't know what. And that is me as a smart cart, just trying to use me to measure my position. Now we can have a look at my velocity. It's not going to be very good, however, and we'll see why. If I change this and look at my velocity, it looks absolutely terrible. We've got some nice figures when we looked at the other smart cart, but this looks awful. Now why does it look awful? Why have we got these up and down, up and down, up and down? Well, it's very simple. If you look at my feet for a minute, and we pardon the clogs and the shorts because it's sort of 30 here at the moment, I walk, stop, move, stop, move, stop, move, stop, turn making a mess. Move, and I stop, and I move, and I stop, and I move, and I stop. And all of this causes this wiggle. So when we look at this sort of wiggle, we see step, 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 stationary, doing something horrible, turning, increasing my velocity, and then it slows and slows and slows and goes quicker and slows, and then I stop. And that looks much worse than my position. And I don't even really want to look at my acceleration, but I will. And my acceleration is all over the place because I'm accelerating and slowing down, I'm accelerating and slowing down, simply because what I'm trying to do is walk. And as I'm walking, I'm changing the speed as I go. So I make really a particularly lousy smart cart, which is why it's better to do the videos of the smart cart rather than anything else. If we look at the graphs that we've managed, then if I set this one up, I've got a cart. So I've got my distance. In physics we use the letter S to represent distance. Time measured in seconds, distance measured in meters. And if I look at 3 different graphs here, I'll make them different colours, it will probably be easier to see. So I've got a slow one, and then I might have a faster one, and then a still faster one. So there's my fast, my medium speed, and my slow. So what we can see from this on a distance time graph is that if we are at a straight line that's parallel to the stop, this is stopped. The steeper the line, and I'm going to use the word gradient here, steeper the gradient, it means the higher the velocity. And that works not just using the smart cart, but it also works using me. So let's go back and we're going to try me once more. So I'm going to do a camera again. So what I'm just going to do is go on to the camera, and what we're going to do is we're going to start this, but this time I'm going to walk that bit faster. So I'm going to get into the right place. I'm going to try and start the recording myself. And off we go. Turn around. And then let's walk back quickly and stop the system. Let's see if we can compare the 2 graphs. So there's my second one. I'm stationary. I accelerate, walk very quickly now towards the camera. I stop, I turn, and I walk back quickly, I stop again, and that's where I leant to turn the mouse off. Let's look at both of those together, and we can see that the second line here is steeper than the first one. So here I can see my velocity was considerably faster, and on the way back this line here is steeper, and we can see that by, if I just bring down a line which I've lost, there it is, and I can get here a measure of my velocity, which was 1.38 meters per second, as opposed to this one back there, seems about 0.72. So I'm approximately doubled my speed, and in the space I've got available, I don't think I could actually get much faster than that. So there we are. There is a distance and a distance time graph. Now let's see what else we can do with this. Well, I suppose I ought to mention one other thing first, and that is that my speed is equal to my distance travelled divided by the time taken. So there's my first little bit. Now let's have a look at acceleration, and for this what we're going to do is we're going to have a look at another equation. I'm going to see that acceleration here equals the change in velocity divided by time. So we're going to do a slightly different experiment now using this track. So let's see if we can change the track to work slightly differently. I've got an end stop here, and what I'm going to do is just move my end stop in a little bit, because what I'm going to place at the end is a little pulley like this. This pulley is pretty good on friction, it spins sort of for more or less forever. What I'm going to do is, this is not going to be a problem, I'm going to shove this right at the end. I've got the buffer in front so that when this cart crashes in, it's not going to collide with my pulley. Now on the front of this cart I've got a little thing so I can connect on a piece of string. I'm going to pass this string over the pulley, and to this I'm going to attach a small weight, and in fact the small weight that I'm going to put on is just 10 grams. Now this is going to cause a few problems. So what I'm going to do is I'm going to adjust this track so that the cart doesn't move, and then I can work out the force of 10 grams on it. I'm going to do that by raising my track up. So I'm just going to lock a couple of supports in place, and let's set this track to the right position. So I want it to just be balanced by this mass, so it doesn't either go up or go down. So it's about there. May not be exactly the right position. I'll see what I can do about changing that in a minute. So we're just about balanced by this 10 gram mass. That if I push it here, it should hold it. Bring it back there, it should hold it. So it's not being moved by this mass. So let's start with putting a 10 gram mass on here and see what happens. So I put a 10 gram mass on, we let go, and we're going to see some acceleration. So our experiment's now ready to go. A new experiment. The hardware I'm going to use here is just going to be the smart cart, and what I'm going to do is look at position, velocity and acceleration, so I might as well do all of those at the same time. So here I've got my position, and I'm just going to make sure I'm using the right thing. And that is my red cart, even though it tells me it's blue. So I'm going to accept that, and what we're going to do is I'm going to set this recording. Let's put the mass over and let go. So nothing was going on, and then we're looking at here, I'll just move this box out of the way, the position. Gradually we can see a gradual change here, the velocity here increasing, however, fairly uniformly, and the acceleration here not looking brilliant. Okay, we're going to do the same experiment again, but this time what I'm going to do is we're going to increase the acceleration. Just had a collision down there. So instead of having one mass on there, I've now got two masses. So you can see here, got two masses just on there. I'm going to hold that. Let's start the experiment. And let's let go. And I'll stop it there. Right, I'll just stop my machine working, make it safe. Now let's have a look and compare the two experiments. So on this graph, I'm just going to bring in the other set of data. So I've got run 1 and run 2. Looking at our velocity here, we can see my velocity was increasing at a faster rate than it did in the first run. Let's try that again, but this time I'm going to do it with a third mass on it. So if I put a third mass on here, gives me 3 masses, that's 30 grams, and what I'm going to do is I'm going to press start and let's watch the cart run. Did a much faster run this time. And we could see our first run, our velocity was slowly increasing. Our second time, it was more dramatically increasing. Our third time, our velocity increasing more. If we look at our acceleration, let's have a look at these. And I'm just going to make these accelerations perhaps a little easier to see. The software has decided to put all these in blue to make my life considerably easier. No, there we are, run colour. Let's make the last one green, and we'll make this one red. Alright, we'll make the next one green then. There. So let's look at our accelerations. The blue one, we didn't accelerate very hard. The next time we accelerated faster, and the third time we accelerated faster still. And you're seeing that again we're not getting a nice even amount of acceleration, but our acceleration here is going faster and slower and faster and slower. Which is just an artifact of what we're trying to do. It's an artifact of this particular machine. So looking at our acceleration, we do this by looking at normally a velocity time graph. So let's go and have a look for a velocity time graph here. in a velocity time graph, what we do is we have something that may look like this. Here, this is with a velocity time graph. Here is our velocity, and you can see our velocity here is increasing, 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 and then our velocity stays the same. And this means a constant velocity. Now, we didn't reach that on our system really very well, and we couldn't quite see it, but we've got our velocity increasing, and this line here showing my change in velocity with respect to time here, this is called the acceleration. And when we looked at my graph, we also had here in my velocity time graph it going the other way, a deceleration. Once the mass had hit the ground, then the cart didn't stay at a constant velocity, and this is simply because this is going uphill here, as you can see towards the printer. As it's going uphill, then it will get faster. When it gets to the top, if we do this again, you can see that it will go faster and faster and faster until it reaches the point where this hits, and at this point we start to see a deceleration because the acceleration is no longer being applied. Now we can see this a bit easier if I do it with just the one mass on there, and I didn't do that well. Right, let's get the string. So let's watch the cart. You can't quite see it really. There's the cart. I'm going to let go now. It's going to start accelerating to this point, and at this point here it's no longer accelerated, but it stops. So I'm going to put my finger there so you can have a look. Let's take the cart. So we're going to have acceleration up to my finger, and from this point it is slowing down. Not that easy to see. But although it's not easy to see, we can measure it on the graph here. So we've got acceleration. If we look at a few of these different graphs, then if I compare this graph with this one, then here we've got a higher rate. So this is, if you like, faster acceleration. One other thing that comes out of these when we start drawing these graphs is the fact that if I take a graph like this, I've got here an acceleration, constant velocity, and here a deceleration. I can divide these up into the different bits. Here is my acceleration, constant velocity, and my deceleration. If I can measure the time here and the time there and here, what we can do is, if we work out the area of these three objects, then what we can do is we can work out the distance travelled. So distance travelled is going to be the area under the velocity time graph. Now we've got this far, what we now need to do is to analyse this in more detail. And there are various ways we can do this. I've been using this Pasco equipment to try and identify what's going on, and it's drawing the graphs very quickly and easily to try and do what we want to do. But there are older systems for trying to do this, of using ticker tape, and sometimes this sort of gives a better indication of what's going on. So sometimes it's worthwhile having a look at those systems as well. So next time we'll have a go at looking at a ticker tape timer trying to do this. I hope you found this useful. If you did, great, please subscribe and give us a thumbs up. Next time we'll look at using a ticker tape timer on GCSE Physics, topic by topic. Until then, stay safe. Bye bye.